Welcome, everyone, to another Silicon Labs product podcast. Today's episode, we will dive into the topic of embedded machine learning. It's also referred to as TinyML. And I'm fortunate to have Zach Shelby. He's the co-founder and CEO at Edge Impulse joining us today. Edge Impulse helps embedded developers integrate machine learning into their products. Thanks, Zach, for joining us today.
Pleasure to be here. Always happy to interact with the Scilabs team.
Sure. And Zach, before we begin discussing machine learning deeper, why don't you do a better job of introducing Edge Impulse to our listeners?
Yeah, so Edge Impulse is something that we founded based on our experience starting to work with 32-bit microcontrollers and this whole wave of new efficient research that was coming out of the machine learning world. And we realized about 3.5-4 years ago that as the power of 32-bit microcontrollers increases, right? We have plenty of Moore's law left to go in our space. We can do amazing amounts of math at very low power, but we're not making very good use of that math. You know, we measure temperature once an hour in the IoT. So we started to bring a lot of this machine learning tooling and capabilities down to the microcontroller level. And what we found is it's really just a match made in heaven by enabling machine learning on these small embedded devices. We can do amazing new things with sensors, with audio, with very low power computer vision. And we can do it right on a low power, wireless footprint. And that opens up just tons of new applications for us in the embedded space. So what we wanted to do with Edge Impulse is open up this world of machine learning and embedded for embedded developers, for the domain expert engineers, somebody who knows thermodynamics in washing machines, for the scientists that work with the data that comes from these devices, and really enable them to take a data-driven approach to their engineering work. So we don't really think of machine learning as machine learning for the sake of it or for the research coolness of it. We think of machine learning as a data-driven engineering tool that everybody should have access to. And that's our mission. We're on a very big mission to open up this technology to everyone. And we're doing that together with Scilabs. And we'll talk about that a little bit more, the new device that we're launching. And what we hope to see is that we just open up all the customer base to be able to make use of this technology.
Yeah, and I think, in the last 5 years, there's been a struggle between how much you do with the data locally and the cloud. For the longest time, we've been pumping all this data up into the cloud, and all these companies are like, we don't know what to do with it. And I think what you're now with Edge Impulse, you're saying, well, it's a balanced equation. You have to do some of it local, and you have to do some of it at the server level. And with TinyML, you're able to balance it better, and you're not just throwing it all up into the cloud. So that's a big task, and I'm sure that you guys will be busy over the coming years. So
that's exactly right. Yeah, it's a balance of, let's get the data out at the edge that we can, and let's really refine it to be information that's useful and when it's useful, and just transmit that information to the cloud. And then there's other machine learning things and data things that we need to do in the cloud, because that's where we have access to everything that's needed. And so they complement each other. It's not a either or.
Exactly. So coming from a traditional embedded design engineering experience, I've always been asked, what size device? I mean, can we really put machine learning? And you talked about the footprint. I mean, these ARM devices, these Cortex devices are, they're designed to be super low power and very efficient. How much of a footprint does the machine learning take? For some of these typical applications where you have connectivity and you have some machine learning on a device, what have you seen for specific applications?
It's really amazing what's possible. I've been blown away, and I've been at the center of this field for the past years. Every day when our team comes up with new innovations in optimization, I'm like, wow, we can do this on a Cortex M0 Plus. Holy cow, right? It's mind-blowing. And so what's happened is that as we've pushed that limit of optimization, we've been able to half the amount of flash and RAM just recently, a couple quarters ago, that are needed to deploy these algorithms. We've been able to choose whole sets of algorithms that are really specific for microcontrollers. So that's been a big help. And then at the same time, right, we're making sure that we're doing all the signal processing we can. So it's also important to realize that more than 75% of what we do when we talk about machine learning on embedded is that we do really, really smart signal processing and called feature extraction before we ever go to a machine learning algorithm, because machine learning algorithms are expensive. And so it's the total opposite of what happens in the machine learning cloud world, which is throw the biggest machine learning neural network you can find at the problem. Embedded machine learning people are the opposite. We're like, throw the most signal processing we have available at this problem, and then let's let this little neural network do its job really well. And as a result of that, what we can achieve today is almost all sensor problems, 3-axis accelerometers with magnetometers, temperature, humidity, simple radars, you name it. We can handle almost all of those signal processing neural network problems on a Cortex M0 Plus with under 20K of flash and 20K of RAM.
Wow! So that's part of your embedded tools that you have on your website,
yep. And that's state of the art right now. You can go and deploy that as we speak, and put that into production. And that's awesome because it fits most of the targets that we have out there in the field today with customers. So this isn't something that right away we're requiring customers to go upgrade, so like a huge new part. We can do audio on a Cortex M4. And by audio, I mean keyword recognition with human language, or machine debugging or predictive maintenance with an audio sensor. We can do that on a Cortex M4 in real time in under 50K of flash and RAM. To give you an idea. Right. Again, very much within the realm, right, of the Gecko series of Cortex M parts. We're also able to do low-end computer vision. So think of this as like low-res cameras, 100 pixel by 100 pixel, almost real-time image classification with neural networks. We can do that on a Cortex M7 class part today. And then when you start getting into more complex computer vision, object detection, this is where you start to get into the Cortex A realm. Not GPUs, just Cortex A is what's needed for that. And then what you're going to see happen is as we get more acceleration, it doesn't really matter what kind, DSPs, neural network processing units, GPUs, in CPUs, what you're going to see happen is that we can do that same machine learning workload a little bit faster, which means lower duty cycle, right? Less power. Or we can do a more complex workload, right, on the same process. So that might move low-end computer vision into Cortex M4. It might move audio into Cortex M0 Plus. And it might, put more complex computer vision into the microcontroller world. So we're going to see, that's going to pull these applications in towards our world of microcontrollers faster. So it's a really fascinating time.
Okay. So I mentioned I went to your website, and it immediately talks about your tools, your filters, your models that you spent a little bit of time talking on it. What's the development experience for customers? I mean, do they go to your website? How would you say the typical engagement is with a new customer with Edge Impulse?
Yeah, so Edge Impulse is a developer platform. We're very, very developer engineer friendly, which means that when we support a hardware platform, so the Thunderboard Sense 2, for example, when that goes live, what a developer will be able to do is just go to our website, create an account for free, and then they're able to use our entire platform. We have a free account that's compatible with commercial use. So a developer working on their own, they're able to do an entire data set collection. They're able to choose from our library of signal processing and ML algorithms. They're able to train and test their algorithm, and then they're able to generate the machine learning library as a small C++ library or as a whole firmware for the Thunderboard. We actually go and generate the entire firmware image, so you can just drag and drop that to the Thunderboard to get a feel really quickly for how it works. And that's all low code. So our approach is we are doing machine learning for engineers. We're not expecting engineers to become data science experts or understand everything that's going on. We want them to understand what the capabilities of this is and how the development cycle works. And we make it quite graphical. So you're able to choose your sensor data graphically, you're able to choose your algorithms and configure it with sliders. And then if you want to do something more advanced, we have low-code extensibility. You can go code your own architecture for a neural network if you get into that, or you can implement your own signal processing algorithm from scratch if you have something really custom you're working with. So we allow people to really extend the platform, including the inference. We do source code for our inference. So you can even integrate the libraries in different ways, send the data somewhere special, do something real time with the data on the device. We let the developer choose what they want with that.
Yeah, and I went there, as I mentioned, and it was a quick, I was able to get started going through your demonstrations, going through your just the resources you have available for me to even get to learn about the topics. It's a great place to go for people to get started. And just, like you said, they can get deep really quickly. So pretty valuable resources. Why don't you talk a little bit more? You brought up the partnership that you have with Silicon Labs that we're starting, and you brought up the Thunderboard Sense 2. Why don't you talk a little bit about where you see that, what the excitement is, and some of the things you're offering with Silicon Labs?
Yeah, we started to engage with the Silicon Labs team when we looked at, well, what would it mean to bring machine learning as an experience into the Silicon Labs product family? And we really quickly latched on to this Thunderboard Sense 2 because it's super suitable for this already, right? It's got a larger size giant gecko part. We have wireless, so we can do things with Bluetooth Low Energy, for example, or with Thread. And we have a nice range of sensors on board. We're starting with the audio and IMU sensors, so the motion sensors, and then we'll expand to additional sensors on the board. And what we do is when we've launched support, which is coming this week, so by the time the podcast is out, you can just go there and try it out. We'll have a downloadable firmware for the Thunderboard Sense too that you can just drag onto the board, and then you open up a command line tool we have that's called the Edge Impulse Daemon. It's just a Node.js tool. It's pretty easy to install. And that will automatically connect the Thunderboard Sense 2 to your Edge Impulse account. It asks your login. It asks you what project you want to connect it to. And once you do that, it's really cool. You can live stream sensor data into your data sets. You basically click a button and say, take a new sample. You can do hand gestures. You can tape it to a machine and debug anomaly detection or predictive maintenance classification on machines. You can do human voice keywords. The sky's the limit. And we automatically, stream that data to your account and let you start working on your ML project. At the end of the process, it's kind of the same. Once you're done, you've tested the project a little bit in the cloud, because the cloud's a lot easier to debug these machine learning algorithms. You'll hit a button at the end where you choose the Thunderboard Sense 2. It will generate the whole firmware. And then you can drag and drop that back to the device and open up a serial terminal, and you'll right away see the inference running, the machine learning running on the board. So no coding required to get that, 5-minute experience. We also have a tutorial coming and a whole webinar later in February 25th, together with Element 14, where our engineers will be showing how to build not just that, but how to build a project in Simplicity Studio, take the C++ library and build some embedded code around it. And we'll have tutorials, of course, on our website.
We'll make sure I'll put that webinar link in the podcast details for all of our listeners. If you get this in time, definitely go and check out the webinar, or it'll probably be on for replay for people that listen to it afterwards. That's great. I think it's exciting. It's something that our company's been looking to engage in. You seem like the perfect partner with your background and your experience and the success you guys are having. So I look forward to seeing all the new customers and the new opportunities that we're going to be able to work with together on. So one last question I have for you, and it was when I first was asked about this podcast, how would you best describe the relationship between AI and ML? I grew up as a kid with Terminator, scared to death of AI, and now I'm doing a podcast, and I'd like to understand how you would differentiate AI from ML. and what the relationship is?
It's really simple. If somebody's talking about AI, they're probably doing PowerPoint. AI is not real. There is no artificial intelligence. There is no, making independent decisions in an intelligent way to decide what's important or what's not. Machine algorithms don't do that. And they don't do that today, regardless of all the advancements in machine learning. Machine learning is the actual math. So if somebody is talking about machine learning, they're probably talking about real math, right? They're talking about data that's used to drive training of real algorithms. And those algorithms are really atomic units that do a very specific thing, right? They'll take in data which has been marked up by experts. They'll use those expert, markings to go and try to learn how to determine those same things as kind of a machine expert, right? And that's all it does. It'll try to identify those same patterns, day in and day out, and it won't change. So we really differentiate that way. When I hear a company talking about AI, I get a little bit suspicious. I'm like, okay, somebody in the marketing department's gone a little bit wild with their terminology. And then when I hear people talking about machine learning, I get interested. So I'm like, okay, they might be talking about something real here and something very practical from an engineering point of view.
Exactly. The true building blocks of doing intelligent things is through machine learning. That's how we're going to get it anyway.
And in our embedded world, right, that's the magic, right? This is data. We should always think about this as even more practical. This is data-driven engineering. This is a whole new wave of how we're going to be designing these systems for the next decade and two. And that's what really gets us excited. This can affect everything we do in embedded in lots of positive ways. And it's just another piece in our stack, right? It doesn't replace all the other wonderful things we do in wireless communications and security and intelligence on device. It just gives us another building block in our toolkit.
Well, Zach, I appreciate the time you spent. This was a great initial podcast. I'd love to have you back maybe after we kick off our relationship and I get more questions from our audience. I'll invite you back and we can do some maybe deeper dives into some of the things you're seeing in machine learning.
Perfect. Thanks, Kyle. Great to be here.
All right. Well, again, I'd like to encourage our listeners to attend the webinar or to listen to the replay. I think that's going to be another great opportunity for them to learn more about machine learning and Edge Impulse and how we're working together with Silicon Labs to provide them solutions for their products. Thanks again, Zach, and thanks to our listeners for taking the time to download our podcasts and learning more about Silicon Labs products. And until next time, everyone, stay safe.